Okay, let's solve this interesting stack problem today, which is main stack. It says design a stack that supports push, pop, top, and retrieving the minimum elements in constant time. We implement the main stack class. Main stack initializes the stack object. Push pushes the element var onto the stack. Pop removes the elements on the top of the stack. Top gets the top element of the stack, and gets min retrieves the minimum element in the stack. And we must implement a solution with O of 1 time complexity for each function. If we look at example 1, the object of the class was created here, and we push 2 onto the stack, then followed by 0 and then 3. Then we call the get minimum function, which returns 3 because 3 is the minimum in the stack. Then when we pop 3 from the stack, we get the top, we return 0 because 0 is at the top of the stack. And then we get minimum again, which is minus 2 now because 3 has been popped from the stack. So let's now try to visualize the example and understand better. Alright, I have our example 1 here. And to solve this problem, we should know we have to use a stack. The only challenging part of this problem is how to get the minimum in the stack in constant time. And to do that, we can use a stack of pairs, where each pair will contain the value that was pushed onto the stack and the minimum of all the elements in the stack. So we initialize our stack like this. Now, when we call the push function with -2, since our stack is empty, we can simply add the value, which is -2, and the minimum will also be -2 because the stack is empty. Now, when we call the push function with 0, we add our 0 and the minimum between 0 and -2, which is -2, indicating that in our current stack, -2 is still the minimum in it. Now, when we call the push with -3, we add our -3 and the minimum between the previous minimum and -3, in this case, which is -2 and -3, which is simply -3. Now, the getMin function is called, so we return the first element of the pair at the top of the stack, which is -3. Now, when we pop, we simply remove -3 from the stack. Then top, we return 0, which is the top element in the stack. And when we call the get minimum again, we return the first element of the pair at the top of the stack, which is -2 in this case. So that's just the whole thing. And now let's move over to writing the code so that we'll be able to understand better. Okay, the first thing we are going to do now is to initialize our stack. So we can do self.stack, which is empty by default. Now, when our push function is called, we want to check if the stack is empty or not. Then based on that, know how we'll append to it. So we can do if not self.stack, meaning our stack is empty, so we append a pair containing the value and the minimum, which is also the value because our stack is empty. But else, we also want to append the value and then the minimum between the value itself and the previous stack value, which is self.stack at -1 at 1, the previous stack minimum. Now, for our pop function, we have to return. Okay, we are not to return, so we just have to pop the item at the top of the stack. Then for the top item, we return the item at the top of the stack. So we can do return and 0, which is the actual value. Then for the get minimum, we return the first element of the pair in the top of the stack, which will hold the minimum in the stack. So we can just do this and change our 0 to 1 so it can get the minimum. So that's it for the solution. Let's now run the code and check if it works. Alright, so it works, and that's it for this video. See you guys on the next one.